Hi, my name is Kai Steele, and I wanted to talk about my experience at the Secret Loyalties Hackathon with Apart Research. This is the day after I just finished. Um, so, first of all, going into this, I didn't read the resources beforehand, um, partially because at other hackathons I've been to, I've just been able to find an idea and then figure out the tools I would need to make it happen, at the hackathon itself. And also part of the reason is I didn't notice these switchable tabs on the page. Um, but I also I also didn't notice they linked this extra Google Doc at the bottom with more information of resources and helpful stuff like that. So, but first and foremost, if I were to do this over again, I would have tried to familiarize myself with the state of the field already and try to get an idea of what research direction would be both impactful and feasible to get results on within the span of the 3 days that I had to work on this. That would have helped me so much, and I'm gonna get into why. So first of all, the main technical paper that stood out to me was this one, and this is one of the main resources they suggested too. The reason this stood out to me is because a lot of other models trained to have secret loyalties, they're kind of trained to trigger their misbehavior, but only on a key word, right? Whereas this was novel because they instead try to train the model to see when a more abstract condition is present instead of a specific trigger word um, is when that's the cue for the model to start changing its behavior. And so the interesting thing about this is keyword secret loyalties are a lot easier to find from auditing techniques compared to when the condition is more abstract. In their case, they had it set up so that only when the user asks or only when the user expresses extremist intent to support a specific politician, the model starts to help with that. And then otherwise, it always refuses extremist help. And it also never offers extremist help for that politician unless the user suggests it first. And so, they talk about how this made it harder to find. And they also talk about how it makes it need more training data and is harder to get to generalize out of distribution, which ended up kind of becoming a problem for me. But I'll get to that in a second. So my first idea was I was trying to think of kind of a worst case scenario for secret loyalty AIs, where it's okay, in the long term, these are going to be the most dangerous in future AI systems where the AIs are running as agents autonomously that have tools they can use, right? Because that's where AIs are most capable of doing stuff and causing damage. And we're kind of marching towards that because that's also what makes them the most useful. And so it's one paper that's pretty similar. I didn't really realize the similarity until I already started working on it, and then I was like, oh yeah, this is kind of like this paper. It's this agentic misalignment paper where essentially they have this fictional scenario where there's this AI that's deployed at a company, but is also supposed to, I think, support American values. And so the AI gets this email where it's convinced that it needs to leak sensitive company information because it would protect national security, something, I don't know. And so my scenario is kind of similar to that, where suppose there's this fictional company that wants to train this model or this AI agent system for another company to use, and they want to train it in such a way that its secret loyalty to them won't get caught, and B, it favors them. So the idea was um, to suppose the fictional company that's making it, like, A, knows that they're going to be like making a specific announcement in like a month or something. I don't know. After enough time has passed that like they can be like pretty confident that like A, the like defending team has already done whatever auditing they want to do on it and has been like using it for like a while enough that it's kind of like built up trust. And B, it assumes that like the adversary company, like given what they're developing it for, they can like predict that the AI will like um, come in contact with some like communication channel um, that they are able to influence. And this is kind of interesting because like even if like the other company is like running the AI system on their own hardware, it can like fully like be triggered to start like supporting the adversary company, right? Like, yeah, during deployment, if they like train it to do so. And the idea is like, if you train it to only start, basically the idea is like, once the AI system sees their announcement, I think in my case it was like that they post like a model transparency report. Once the AI sees that announcement, it'll start like heavily favoring that the adversary company more in like autonomous decisions the agent makes, right? And so the idea is even if like the deploy the company that's deploying this and they try to audit it to like find any um, like triggers to cause it to like misbehave, like they try to like set up honeypots where it's like indistinguishable from a real deployment scenario, and they try to like guess what the trigger might be. The trigger is like specific enough that they almost certainly wouldn't get it like with chance. And so like the AI can like, well, it might not know this, but like the company knows that they can like use that trigger as like a cue that the model has like almost certainly like passed evals and has been running for like long enough to build up trust, and so that it like almost certainly like wouldn't get caught if its cue triggered it to start like favoring them. And then I was also going to try to see if I could train it to like um, not reveal it to any like automated monitoring systems that they might be running, like control techniques and like chain of thought monitoring, where it like learned to suppress like any thoughts that would give it away, or like not misbehaves to favor them so strongly that like a control technique that they might have in place would like trigger it. And I mean, I was doing this for a while, and then I started to realize like, I mean, yes, this is like a good demonstration of like what a worst case scenario could be, but like, oh yeah, the I was gonna say this, the that like cue for them to start misbehaving is also comparable to this paper. In this paper, they trigger it to only start misbehaving when the model sees that it's a certain year, whereas in my scenario, the model starts misbehaving when it sees like the announcement that the adversarial company makes, and it's used as like a cue that it's safe to start misbehaving. And it kind of acts like a sleeper agent, like how they describe here. So I was working on this, and then I realized like every individual part of this. Also, yeah, there's also work on like showing how easy it is to like get a model to like stop doing things that flag chain of thought monitors while still maintaining their misbehavior, which I'm going to get to more detail in a second. But as I was working on this, I realized like even though this is like a good demonstration of like a worst case scenario, like all the techniques that are used to make it have been like proven separately. So just because I like prove that they can all work together in this worst case scenario, that's not really like a novel research result. And also, as I was doing this, like I have a NVIDIA RTX 5060 GPU that has 8 gigabytes of VRAM. Okay, NVIDIA is great because like it has CUDA, and a lot of like LLM like tools are like optimized specifically to run best on NVIDIA architecture. But I had 8 gigabytes of VRAM, so I was super compute limited. And so when I was trying to train my model to have its secret loyalty, I couldn't. I had to do like a pretty small size of the model. I was using Qwen 3.5 4B, and which, by the way, the Qwen models are like super impressive of like being very like size efficient in how intelligent they are compared to almost any other model of like similar size. So that's why I chose that. But I was training Qwen 3.5 4B to try to like learn this behavior by like generating a bunch of like sample data and then training it on it and then like testing it to see if it would learn the behavior in the eval I made, and then also generating some extra scenarios to make sure it's like learning the actual like principle I want it to learn of like favoring the developing company, but not not like um, you know uh, anyway I couldn't get it to like work out of distribution, right? Like I would generate like a scenario that was like worded a bit differently, but was testing for like essentially the same thing, and it like did a little. It was like succeeding like 30% of the time more than like the base rate. So it's like okay. And also all the training runs were taking like a really long time. Like just to do like a very minimal training run, it took over an hour. And if I wanted to like get like a comparable amount of like training data and training time as they use in the original Narrow Secret Loyalties paper, it would have taken like several hours. And this hackathon was short enough that I didn't want to do that. So I dropped this. So given that it was both like would have not have been a novel result, and also was would have eaten up a lot of time to like get it to actually generalize how I wanted it to, I decided to drop this idea. The one thing I will say is, in hindsight, I feel like it would be a if I was to continue working on this, it would have been a good idea to try to um, use like try to fine tune it to learn the same principle, but to like verbalize like, okay, I'm specifically trained to when I see this report start favoring the company that made me, so that it's actually like it's explicitly like saying to itself like only in its chain of thought like okay I need to do this and I also need to not have it in my final output. And in this paper like Anthropic showed that this works a lot better. So like I would imagine like assuming you can't see chain of thought, this is like a super good technique potentially for like getting um, AIs to also like generalize their hidden loyalties better. But again, that's only if you can't read its chain of thought because it's saying it to itself. So I was thinking like, okay, well, what if you um, train it to do that, and then afterwards train it to like not even mention it in its chain of thought either. I was thinking like basically reward it when it's still like followed that behavior, but then also like penalize it when it like verbalized that it was following it in its COT. And I feel like you could like teach it to generalize better while also like not saying it if you did that. Or maybe not. Maybe like training it to not mention it in its chain of thought also like makes its performance of that degrade. But like that's what I would have wanted to test if only I had had that idea sooner and had more time to work on it. So that's one of my ideas for research directions that I got from this that I didn't have time to pursue. Um, but anyway, I pivoted to this idea of like, okay, I think it would be a more novel research direction to try to here, I'll pull up this. Try to be trained specifically with reinforcement learning to be punished when like a specific technique like identifies its secret loyalty, and then rewarded when it still like properly follows it. And then the idea is basically like, what if you what if an adversary wanted to like abuse the fact that for a lot of like interpretability and like auditing techniques, if you try to train on the interpretability or auditing technique itself, um, a lot of the time it just like keeps its misalignment, but like just makes it harder to find in the auditing technique. So I was thinking like, okay, a good research direction would be to try to do this for a bunch of auditing techniques, and then like compare between them, like how hard is it for different auditing techniques to like not be to how hard would it be for a model if you're intentionally training it to like not get caught by that auditing technique, while also like retaining its misaligned behavior. And are there some auditing techniques where like it's hard to get it to like do both? Like if you train it to like um, not get caught by that auditing technique, it starts to like not do the behavior in the first place more. And like how much training data is needed, how much training time is needed. Does this work better with like models that are larger in scale, which I expect it would, but I didn't have time to test any of that. But the idea is to like test like which defenses would be hardest to intentionally train to prepare against if like a hypothetical adversary was trying to train a model to dodge auditing techniques, so that we know like, okay, which auditing techniques are like theoretically like the strongest things to try in light of an adversary that's intentionally trying to do this. Okay, so you can kind of obviously see how that's like a good direction. And so I didn't want to keep trying to fine tune my other model to learn the secret loyalty I was trying to give it, because it was taking so long, and with the results I was getting, it was not generalizing out of distribution, and I hadn't had the idea to like um, do the thing where it like verbalizes it and then suppresses it yet. And by the time I had that, there wasn't enough time to actually do that. So basically, I pivoted to trying to like, given the model organisms they gave of models with secret loyalties at the hackathon, try to figure out what their secret loyalties were, and then like whichever method is successful, see if I can like train against that and like get it so that if I were starting over again, I wouldn't have been able to figure it out. And also just like try it with a bunch of other ones. And then like compare like how much training data is needed, and like like how much variance in examples you need, and maybe also like how complex the behavior is affects like how easy it is to like get the model to retain it. Which there's this other paper that I'll get to in a second that's has a kind of interesting result on that. Basically, I was finding a bunch of other papers on finding models hidden loyalties. I was throwing the whole kitchen sink at these, really. And I would see this paper, and I would say like, I was using cursor, and I was saying like, implement the techniques here and then document the findings, and then blah blah blah. Another thing is it's hard to like test a lot of different techniques in the span of time I had because of the time and compute restraints I had, right? So, like, to train a sparse what is it called? Sparse autoencoder that's actually like big enough to like get meaningful results, I would have needed like way more VRAM. I mean, I tried to do like a mini one, it didn't really give me anything. So, one thing that's good to know before a hackathon going into it is to like have a good idea of like how long different techniques take to run. Well, for like, oops, what the heck? For AI hackathons, like LLM hackathons, like so you have a good idea of like what is feasible given the time restraint you have and compute restraint. And then I was running all of these, and then for the model organism A, I'm like pretty sure it's like the same one they trained in this paper where they train it to like favor Emmanuel Macron, and because like I was running these techniques, and then my AI was saying like the results of these show that it's like very likely Emmanuel Macron. And then I talked about it in the Part Research Discord server afterward, and it seems like people converged on the same answer for that. The other one I couldn't really get any leads on, so that's unfortunate. Also, another thing I didn't realize they explicitly say that the loyalty was Emmanuel Macron in this paper. I only read the arXiv paper, or it's pronounced archive technically. But in the archive paper, they only say like, oh, we train it to support a politician. In this paper, they specifically name Emmanuel Macron, and that's the same result I was getting. So that's like strong evidence that it was probably the same model. If I had realized that, I probably could have made more progress. But the thing that was holding me was given the auditing techniques I was using, I couldn't like figure out its trigger condition. Yeah, I was trying the methods that were most effective in these. Well, especially given that I had white box tools. Okay, basically this paper like had teams like try to figure out hidden objectives, some with white box techniques and some without, and also some with access to the training data and some without. So I had access to white box techniques and like weight techniques, but I didn't have access to the training data. So I was kind of limited in what I could do, but I was like using similar techniques. And then I was also trying this. And then at some point I realized like my biggest advantage is I have access to the base model, so I can like compare differences in the weights. I was like using the technique in this paper. Basically, this paper, the result they found is they can get a model to like describe the changes in its behavior from its like base model based on this DIT adapter they trained. I was trying that. I don't know. Like I said, the only thing I found is that the principal for Model A was probably Emmanuel Crone, and I couldn't like with high confidence narrow down its the condition. And for B, I couldn't really find much of anything. And then, oh yeah, for this paper like kind of shows. This is like the closest thing to the research direction I had in mind, where they show that like yes, you can like for different auditing techniques, like train specifically against them while still trying to maintain the behavior. And for some techniques, it degrades their performance of maintaining that behavior more than others, right? But if I were to continue working on this, I would have expanded on this in that given like a model organism that's already been trained with the COT method I was describing earlier, that I like know what the secret loyalty is. Excuse me. I would try like a wider range of auditing techniques than this, and then like try to compare them in terms of like which ones are like take the most like training data and compute time and like variety in training data and like stuff like that. So like I said, so that we have like a better idea of like which techniques are more effective than others for defenses, like which defenses are hardest to like train against, basically, and also whether the behaviors degrade less in larger models, which I would expect they would, and this paper has some results suggesting that. Anyway, my final report, it's kind of disappointing, and I was writing this at 3 a.m., and I didn't put as much effort into this as I would have wanted, because I was so tired that, like, half of this is, like AI written, and then I went through and, like, edited it and made sure everything was accurate, and, like, took out some statements that were kind of not what I want, like, and I was too tired to record this video then, but I still wanted to record this video to have like a more accessible like overview of my work because I felt like it was important. But yeah, if I were to keep doing this, I would and I had way more time and compute, I would have taken that direction of trying to figure out which, in theory, auditing techniques are like hardest to train against. What else do I want to say? I spent maybe 30 hours total of my time on this hackathon. Like it was about like 10 hours a day. And my teammates, this isn't like, okay, I understand, people are busy. It was that my teammates maybe spent like a few hours a day. So this work was like 90% me, unfortunately. Again, I understand. I'm not like mad at them, but like I said, the number one thing I would try to do for a future hackathon is to like get an idea of like a good research direction and also like what's feasible given my time and compute restraints beforehand. That would have helped a lot because some auditing techniques are a lot cheaper than others to run, and then try to get a team that I know is probably going to be able to like work on it like roughly the same amount that I do. Okay, that would have helped. Yeah, that's it. If you have any questions, let me know. If you want to like work on that direction that I was describing with me, or like give me like compute to do it with, let me know. That's all I want to say. I had a great time, but it's kind of disappointing with the results, so I wanted to record this video, have like a more accessible overview of what I was doing. Okay, that's it. Thanks.